Hello again, everyone. So in the previous videos, we've talked about Lewis dot structures, molecules that use valence electrons to say something about how bonding happens in a molecule, either ionically or covalently. And so we talked about how to look at a Lewis dot structure and say something about the bonded and lone pairs of electrons on the central atom. We can also use Lewis dot structures to explain ionic and covalent bonding, but specifically we can address this topic of why you should have no fear of ice cold beer. So if you remember that, that little mnemonic was from a previous chapter. We said that you should remember have no fear of ice cold beer because those are the elements that like to exist as diatomic, dia meaning two, diatomic molecules. And when we talked about have no fear of ice cold beer, I said just take my word for it that hydrogen likes to exist as H2, not just individual hydrogen atoms, etc., etc. Now we can finally talk about a theory that explains why halogens and hydrogen in particular like to form diatomic molecules. And it becomes apparent when we look at the atom's Lewis dot structure and remembering the octet rule. So with regard to the halogens of have no fear of ice cold beer, specifically chlorine, fluorine, bromine, iodine, all of those atoms, when you do their Lewis dot structures, have 7 valence electrons. And we know from the octet rule that atoms want to beg, borrow, steal, do whatever they can, so they have 8. So you could envision another chlorine atom donating its unpaired valence electron to another chlorine atom to give you something like this. Remember, those shared electrons are in between the two atoms. They form a bond. So that explains why chlorine, fluorine, bromine, and iodide like to be diatomic, because once they are diatomic, then each atom has an octet of electrons. And to convince yourself of that, you can go ahead and count the number of electrons for each atom. So remember, electrons that are in between the atoms as a bond get shared equally, so they get counted twice. So if I was to count the number of valence electrons for this chlorine atom, I have 1, 2, 3, 4, 5, 6, 7, 8. A single bond gets counted 2 electrons. So this chlorine has 8 valence electrons. This chlorine also has 8 valence electrons. 1, 2, 3, 4, 5, 6. Remember, they're shared equally, so they get counted towards both atoms, 7, 8. So this guy has 8 valence electrons as well. They are both happy. They both have satisfied the octet rule. So that is why chlorine, fluorine, bromine, and iodide like to be diatomic, because being diatomic satisfies the octet rule for them. Now with regards to hydrogen, when you look at its Lewis dot structure, it only has 1 valence electron. Hydrogen, we said, likes to have a duet. It wants to have 2 valence electrons. So then you can easily see that one hydrogen would like to pair with another hydrogen, share those electrons, and thereby each hydrogen in this diatomic molecule now has 2 valence electrons, because remember, these electrons get shared equally and get counted towards both atoms. Okay. So that takes care of chlorine, fluorine, bromine, iodide, and hydrogen with regards to why they're diatomic with regards to the Lewis dot structure theory. But if you remember, have no fear of ice cold beer, we still have oxygen and nitrogen to talk about. They like to be diatomic. Can we still, can we use the Lewis dot structure theory to explain why they are diatomic? And the answer is yes. So here's oxygen. Here is the Lewis dot structure for oxygen. It's in group 6, so it has 6 valence electrons. You can envision another oxygen coming by wanting to share electrons with it. And sharing one pair of electrons, this oxygen on the right-hand side is happy, meaning it has an octet. 1, 2, 3, 4, 5, 6, 7, 8. But this oxygen on the left-hand side is not happy. It only has 1, 2, 3, 4, 5, 6 valence electrons. So how is this second oxygen going to get an octet? Well, it can ask this oxygen on the right. This oxygen has 3 lone pairs of electrons just hanging around on that oxygen, not doing much. If one of those lone pairs can be shared in between the 2 atoms, which is what's shown by the blue arrow here, then that pair of electrons can be shuffled in between, and so now we can have something that looks like a double bond. We've got 4 electrons in between those 2 atoms. And as we said, electrons in between atoms get shared equally. They get counted twice. So now let's see if both oxygens are happy with regards to the octet. This oxygen on the left has 1, 2, 3, 4, 5, 6, 7, 8. So this one has 8 valence electrons. The oxygen on the right also has 1, 2, 3, 4, 5, 6, 7, 8. It also has 8 valence electrons. So not only does the Lewis dot structure predict correctly that oxygen is diatomic, but it predicts that the bond in between those 2 oxygens is a double bond. And experimental evidence shows that that is indeed the case. Last example we're going to talk about is nitrogen. We said nitrogen is one of those have no fear of ice cold beer. So here is the Lewis dot structure for a single nitrogen. It's in group 5, so 5 valence electrons. If it pairs with another nitrogen, we can have some shared electrons in between those 2. And the way that this molecule is written as it is, neither nitrogen is happy. Each hydrogen only has 1, 2, 3, 4, 5, 6 valence electrons. But to get 8 valence electrons, you could see or envision the sharing of lone pairs of electrons from each nitrogen, which is shown here by the blue arrows. And when that happens, when those lone pairs shuffle in between the 2 atoms, they are shared equally. Thereby, in this case, since we've got 6 electrons in between, thereby we have a triple bond. Now we can see that nitrogen is diatomic, and it also satisfies the octet rule. This nitrogen on the left, how many electrons are around it? It has 1, 2, 3, 4, 5, 6, 7, 8. So this nitrogen on the left has 8. This nitrogen on the right also has 8. It has the lone pair here, 1, 2, and also the electrons in the middle, 3, 4, 5, 6, 7, 8. So not only does the Lewis dot structure theory predict correctly that nitrogen is diatomic, but that the bond that is in between them is a triple bond.